Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. Today we're jumping into a 9th grade topic, adding and subtracting polynomials. If you have any questions about what we go through today, or maybe even some of your own homework, remember you can always visit me on Facebook at Tutor Me Senpai and tell me about it there, or simply put it in the comment box below. If you find this video helpful, remember, leave a like, it really helps the channel. And while you're at it, hit the notification bell and smash the subscribe button so you know exactly when I drop my next videos. Well, without further ado, let's jump into adding and subtracting polynomials. So today I'm going to show you a couple ways that you can add these two polynomials, and I hope that one of them resonates with you. So the first way that we're going to cover today is going to look very similar to how you would add regular numbers. So let's say you were adding 105 and 93. You can simply add across, but some people add down, like this. So you could do it this way, and you get whatever number, or you can do it this way. The first method is going to be looking at adding our polynomials in this fashion. You can call it the vertical method, in which you're going to be putting one polynomial at the top and the other one on the bottom, and you're just going to be adding down. So how would this look when you're dealing with two polynomials instead of numbers? Well, the first thing you want to do is look at your first polynomial and figure out what is the highest degree for that polynomial. You will see here that we have the 7n to the 5th. 5 is the highest degree for our polynomial. So we start with that. 7n to the 5th. Then we're going to add every degree below that until we get to our constant. Now, most of these are going to be placeholders just for the math, and you're not actually going to have them be in the actual value. And you'll see what I mean. So n to the 4th. Do we have an n to the 4th here? No. So we put a 0. And we do that because we want that to cancel out so we can ultimately have this long string be this. How about n cubed? Do we have an n cubed for our first polynomial? No. Once again, we put a 0. How about n squared? Yes, we have a 4. How about n? Yes, we have a -3. So I'm going to actually remove that plus and put a -3. How about a constant? Do we have a constant here? No. So we're going to put 0. So you see this 0 cancels out that n to the 4th. This 0 cancels out the n cubed. And this 0 means that we don't have any actual constant that's not attached to a variable. So I recommend writing it out in this fashion because there are times where your polynomials will have various amounts of variables and some may not necessarily match up with what's up here. So we have these placeholders that we're going to use to make sure things line up properly. So let's look at this one. What is the highest degree that we have here? Our second one has n to the 5th as well. So we're going to simply put that down here. But let's make sure we take into account whatever sign is outside this parentheses. Since this is a plus, nothing happens. If that was a minus, we would have to switch all the signs first, but we don't have to worry about doing that. So because it's a plus, we're going to put our plus here. And we bring down this 5n to the 5th. And then we do the same thing. We have an n to the 4th. We have an n cubed, an n squared, an n, and we have a plus constant. Okay? Do we have an n to the 4th here for our second polynomial? No. So we're going to add 0. How about an n cubed? No. So we add 0. N squared? Yes. So we add 2. How about an n? Yes. So we add 8. And do we have a constant? No. So once again, we have a 0. So in this case, it seems like everything kind of lined up from one polynomial to the next. So you didn't really need these placeholders. But here's how you would use them just in case they didn't. Anywhere there's a 0, let's just cancel that out. So you see, when we erase everything that doesn't have a 0, we have our first polynomial up top and our second polynomial in the bottom. However, they're grouped together in something we call like terms. So you see the n to the fifths are together here, the n squared are together here, and the n's are together here, and there's nothing else that is here that's not matched up with its counterpart. This is what we call grouping like terms. Now we don't need to keep this all the way over here, so let's bring this in a little bit. And this is going to be how we would set up adding two polynomials in our vertical method as if we were adding two constants. Since we're adding everything and not subtracting, we can simply add down. This -3 plus 8 is going to give us a positive 5, and we bring down the variable. The variable does not change. Whether that was an x or a y or an n, it does not change, it just comes down. We keep the variables the same, and we just simply add the coefficients. So that means this n squared is coming down, and this n to the fifth is coming down. This 4 is positive, we're adding it to a positive 2, so we get a positive 6. This 7 is positive, we're adding it to a 5, so we get a positive 12. And our final answer is going to be 12n to the fifth plus 6n squared plus 5n. This is our final answer. So now that we've talked about adding it vertically, let's look at the second method I have for you. So I moved our answer down here so we can keep this and compare it to the second method and make sure we get the same thing. So instead of adding everything down vertically like we would when adding two constants, I would like to kind of keep everything horizontal. The first thing we're going to have to do is distribute and drop the parentheses. So for our first set of parentheses, we don't have to do anything because there's no negative in front, so we just bring that down. And if this is a negative, you would distribute and then bring everything out of the parentheses because we would no longer need the parentheses. However, this is adding, so nothing happens. We simply drop the parentheses. Now that we distributed and dropped the parentheses, we have one big polynomial. And no more parentheses to kind of get in our way. So let's move to the next step. And that next step is going to be grouping like terms and combining coefficients. And it's going to be very similar to what we did in the first method, in which we put everything on top of each other and we kind of consolidated stuff where everything was kind of paired up. That is the whole point. Like terms are going to be pairs. You wouldn't group an n to the fifth with an n squared. That doesn't pair up, so we're not going to do that. Like terms, like you saw, means that n to the fifth has to go with another n to the fifth, and n squared has to go with another n squared. That is what grouping like terms means. So we have a lot of terms here. Let's make sure that we're grouping things, and we're not grouping things in such a way where we're counting things multiple times. We want to make sure we count it once and only once. So everywhere there is an n to the fifth, I'm going to use different markers here, but you can use shapes however you want. But let's put a square around it. Anywhere there's an n to the fifth. So is that an n to the fifth? No. 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 Yes. So we put another one. Make sure you put the sign in there as well. We want to make sure we're keeping the sign. And is that an n to the fifth? No. So we have our boxes are going to be our n to the fifths. How about our n's? So we put a box around n's, or matter of fact, in case you don't have different colors, instead of the box, let's put a circle. Circle around n's, is that an n? Well, that is an n, but it's an n squared, right? Just an n? No. We already have a box. Just an n? Yes. So we put a circle. Now our n squareds. And forgive that, that kind of bled over a little bit. But we have a positive for n squared here, so let's put like a diamond around this. All right? N squared, diamond. and no more. So you see, we're pretty much playing the matching game when we have these different variables within our polynomial. If we match it properly, then we can just simply pair them up and add them. Add their coefficients at least, right? So all the squares. The squares are going to give us 7n to the 5th plus 5n to the 5th. The circles will give us negative 3n plus 8n. And the diamonds is going to give us 4n squared plus 2n squared. And remember, whenever you're adding these, you don't do anything with the variable, you're simply combining the coefficients. 7 plus 5, 12, n to the 5th, negative 3 plus 8 gives us a positive 5n. 4 plus 2 gives us a 6n squared. So now that we've grouped everything and we did our individual math, we can combine this into one big polynomial. Notice everything is positive. So we start with our highest degree and then we go to our next highest degree. And to kind of keep things consistent, I'll keep switching colors. Plus 6n squared plus 5n. So if you see that we got the same answers here, that lets you know you can use either method, whatever one you feel most comfortable with. Whether you put it on top and you write out everything and kind of get rid of whatever you don't need, or you simply distribute everything, drop the parentheses, and then group stuff, do your math, and then combine. Either way, you're going to get the right answer if you do your math correctly. And when you get really comfortable doing these addition and subtracting of polynomials, you can kind of skip some steps. So instead of writing out all the shapes, you can kind of eyeball it and then, hey, this n has a 5 as an exponent, that one has a 5 as an exponent, combine those, and then just simply write it. Well, I hope you're able to follow on today's example. If you have any questions at all, remember you can put them in the comment box below or visit me on Facebook at Tutor Me Sempai and tell me all about it there. If you have any questions about your own homework let's see on this channel, visit me on Facebook again, and you can also drop that there as well. If you found this video helpful, remember to leave the like, it really helps the channel. And while you're at it, hit the notification bell, smash the subscribe button, and share with a friend who also might use the help. Well, that's all the time I have for today. I really hope to help with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.